8th, chapter number 3, force and pressure. Okay, so today's topic is buoyant force or buoyancy. Okay, now what is buoyancy or buoyant force? So let us consider a tank filled with water. Okay, we have taken one vessel which is filled with water. Now I am placing empty bottle. Okay, so here is one empty bottle and another one is filled bottle, means bottle filled with water. Okay, so we are placing two bottles in this particular jar or vessel which is filled with water. Here this is empty bottle, means nothing is in the bottle, and in this we are having, in the second bottle we are having filled water in it. Now what two things you will observe, that this bottle is floating on this water and this bottle is inside the water. What is the difference between these two bottles? One is filled, another one is empty. Okay, so you will see that some part of the bottle is inside the water, not actually it is above. Some part is. Why? Because this particular bottle will have gravitational force. What is gravitational force? Gravitational force means to every object there is force which is in downward direction, which is pulling it in downward direction. Okay, so here this bottle is having gravitational force. Okay, this bottle is also having gravitational force, but here gravitational force is more as compared to this. Now this gravitational force means I can say weight of both the bottles are different. Weight of both the bottles are different. Why? Because weight depends on mass into acceleration due to gravity value m into g. Now g is same for both these bottles, but mass is different because I already said this is empty bottle, this is filled bottle. This bottle will have more weight, this bottle will have less weight. Okay, now due to this, these bottles are going in a downward direction, but why not sinking in? Why this also not? Okay, this we can understand due to hollow, it's hollow from inside, so it might be not going, but actually water is applying its upward force on these two objects. Okay, so what? Every time water, liquid or gases, which is called as fluid. Fluids means which can flow. So here liquid can flow. So I have taken water. So water will apply upward force to this object. So to this object also and to this object also, and it depends on the gravitational force. Okay. So here there is opposite upward force to gravitational force. So upward force acting on the object in fluids is called as buoyant force or buoyancy. So we are having buoyant force acting on the bottle, which is upward force, which is pushing it in upward direction. That's why the bottle is not sinking in. What about this? Why it is not being sinking here? Why? Because still I can say that here the gravitational force and this buoyant force, they are balancing to each other. They are trying to balancing to each other. So we can see balanced buoyant force and unbalanced buoyant force. Okay. So in this case we can see that this bottle is at the where? At the filled part, or I can say at the half filled part. So I can say here buoyant force and gravitational force are exactly balancing to each other. That's why it will be here. But here what? Here you can observe we are having gravitational force less, okay, and buoyant force is more. Okay. So this is said to be buoyant force. Upward force acting on the object means every object which we are putting in the water or fluid, it pushes it in upward direction. So who is pushing? This water is pushing to these objects. Okay. So now let us see on what things it is depending. Suppose we are look into its volume of object. Volume of object. Okay. Now consider this is water. In this I am taking one thin thin sheet of aluminium foil. Aluminium foil we are having now. Just I am placing it in this water, and same water I am taking. Same, what I am doing, instead of sheet, aluminium thin sheet, what I am doing, I am crushing that volume foil. If we crush that aluminium foil, its volume will change. Now its volume is greater. Volume is greater. What I did, I crushed it. You can try this activity at home, children. So volume is less here. Volume which is in contact with the water is less. Excuse me. Here volume is more, which is in contact with the water. Now what will happen? What you will observe that this sheet is above the water. It is floating on the water. Why? Because volume of this object is higher. Okay. Hence, its buoyant force will also be more. Which is buoyant force more means pushing will be more. Hence, it is what? Floating. Here what happened? Volume decreases. In this area, less buoyant force. Only this much volume will exert buoyant force. Due to it, less buoyant force will be. So, I can say that volume increases of the object, buoyant force also increases. Volume decreases, buoyant force also decreases. So, buoyant force depends on the volume of object. Second condition. Density of water or density of liquid we are using, or density of fluid. Density of liquid. Water I will take. Density of water, density of liquid, anything you can take. Okay. So, density means what? Mass upon volume. If we are taking same volume and mass is changing, then its buoyancy force will also change. Okay. In previous case also we have seen, here volume we are taking same, one is empty, one is filled. Now, here density is more or here density is more, this object is having more density. So hence what? More what we will have. So this object will sink, it does not depend on this density. Density of this fluid. Now, if we take salt, if we put salt in this particular water. Now, whose density is more here? Its density is more. Its density is less because it is empty, this is filled. Okay. We are not talking about density of water, we are talking about density of water. Now, what I did? I changed the density of water by adding some impurity in it. Suppose I am adding salt in it. Salt gets dissolved. Now, what will happen? When it changes its, if you are adding something in it, definitely its density will increase. Density is increasing. What will happen? You will find this now. This object moves in, this particular bottle filled with water will go up because its buoyancy is increasing. Why? Because added salt. Because I am changing the density. Okay. So if density of water changes, if it is increasing, buoyant force increases. If density decreases, buoyancy force also decreases. So this change makes this difference. Okay. So that's why you might have done or not. In swimming pool, if we are having pure water, if we are swimming in pure water, what will happen? Its density is less. Pure water means only water is there. No impurity is added. Impurity means here does not means any pollution. I am talking about impurity or salt. Okay, anything you can put in it. So which is dissolved, which can be dissolved. So you know that when salt we are adding, or if you are having impurity added water, its buoyancy will be more, which will push you in upward direction. So that's why in swimming pool, if you take a swimming pool and in that salt is added, it will push you up. What? Its buoyancy is more, so it will not make you sink in the bottom. You can float easily. That means you can swim easily. If you add impurity in it, sorry, if in pure water you cannot do. Why? Because its density of that particular water is what? Less buoyancy force. Less buoyancy force means it will not make you push in upward direction, which will make you hard to swim. And if you are adding some impurity, its density will increase. Salt, if you are putting, its density increases, and due to increase in density, it will make you to float up, which makes you very easy to swim. That's why in sea water you can swim very easily as compared to in pure water. Why? Because of change in density. You know that in sea water we are having lot of impurities, okay, which makes it hard water and which makes you to float, which increases its buoyancy. Whose? That water. So water is having buoyant force applying on every object in the same way. Okay, now let us see last topic, that is Archimedes principle, in the next class.